When mentioning circular array, we usually think of the array modifier. For example, we have a monkey head mesh in the scene. Then add an array modifier to it. Change the shape to circle, make the count of 8, and radius of 4. Finally, we have a circular array of 8 monkey heads. But today I'm gonna show you another way to make the same result by using instance vertices. After removing the array modifier from the monkey head, let's add a circle to the scene. On the Adjust Last Operation panel, change the vertices of the circle to 8, and its radius to 4. Now make the monkey head parented to the circle by selecting the monkey head, hold Shift, select the circle, and use the shortcut Ctrl+P. Choose Object Heap Transform. In the outliner, you can see that the monkey head is now directly indented under the circle. In Blender, Instance Vertices allows you to replicate child objects at the location at every vertex of the parent object. In the circle's properties, select Vertices for instancing. Now we have 8 monkey heads on each vertex of the circle. However, they all look the same direction with the original one. To make them face towards the center, check Align to Vertex Normal. You can adjust the way those instanced objects are oriented by changing the tracking and upaxis of the original monkey head. For example, changing the tracking axis to -y while keeping upaxis on z will make them facing away from the center. So how do tracking and upaxis of the child object work to make the way each instanced object is oriented on each vertex of the parent object? Let's name the only collection result. Create another collection and name it Predict. Hide the result collection. Add the same monkey head and circle under the Predict collection to the scene. Enable Object Gizmos for local translation. Enable to show axis of the selected monkey head in the viewport. Show the global z-axis. What is the up-axis? It is a local axis of the selected object parallel and in the same direction with the global z-axis. What is the tracking axis? It is a local axis of the selected object collinear and in the same direction with the normal of a vertex or face. In this case, to show the normals of vertices of the circle, switch to the Edit mode. In the Mode Overlays, enable Vertex Normals. Their size can be changed for a better view. Tracking axis must be line up with these normals. Now let's guess how the array appear if changing the monkey's tracking axis to positive x while keeping up axis, z. In this operation, we need to adjust the up axis first and then the tracking axis. Because we didn't change the up axis, let's head to adjusting the tracking axis. Now we choose the vertex of the circle in the positive global y-axis to perform the adjustment. Move the monkey head there. Because the tracking axis, or the local positive x-axis of the monkey head, is now perpendicular to the normal of the vertex, what we should do is rotate the monkey head at 90 degrees around the up axis, so that the tracking axis is collinear and in the same direction with the normal of the vertex. We can extend the normal line for the better view. Next, select and adjust the tracking axis and up axis of the monkey head child object in the result collection. Finally, compare the orientation of the generated child object at the same vertex with the monkey head in the Predict collection. As you can see, both of them fit in each other perfectly. Some of you may ask, what if the tracking axis is the same with the up axis? That's easy. After moving the monkey head to the desired vertex, rotate the tracking axis around the axis that is perpendicular both the tracking axis and the normal. Unhide the result collection to compare. It works, doesn't it? Let's make another example. This time we change the up axis to y, and the tracking axis to -z. First we must adjust the local y-axis so that it's parallel and in the same direction with the global z-axis. Next, move object to the desired vertex. As you can see, the tracking axis or -z-axis is now on the opposite side of the vertex normal. What we should do is to rotate the monkey head so that its local -z-axis is collinear and in the same direction with the vertex normal. Change the tracking and up axis of the child object. Unhide the result collection to compare. It works again, right? If you want to turn those instanced monkey heads into real and separate objects, select the circle, right-click and choose Make Instances Real. As a result, there are 8 separate monkey heads generated in the outliner. We can make vertex instancing with other shapes of parent object. For example, we have a star constructed with 16 vertices as a parent object, and a pair of chain links as its child object. Select the parent, enable vertex instancing, and check Align to Vertex Normal. Now you can play around with this family by selecting the chain link child object. Change its tracking and upaxis to see how instanced objects are oriented.